Hey guys, I want to go over a few different types of problems that'll be on the homework today. And so the first one is what we're going to be doing is finding probability. And so I want to go over a couple types of probability questions. So this one says, what is the probability of rolling a 3 on a fair die? And that's just a six-sided die. So you've all, when you're playing games, roll the dice, and there's 1 through 6 on it. So to figure out the probability, we take the event over the total outcomes. Now, what that means is how many threes are on a die? Well, one. So there's one way for that event to happen. So the event that we're talking about. So if it would have said, what is the probability of rolling an even number on a fair die? Well, how many even numbers are on a fair die? So it'd be the number 2, the number 4, and the number 6. So there would be 3 different ways to get an even number, and so 3 would go on top. But in this case, there's only one way to roll a 3. And how many different numbers can we roll? Well, we can roll a 1, a 2, a 3, a 4, a 5, or a 6. So there's 6 different outcomes. And so the probability of rolling a 3 would be 1 out of 6. Again, if I'd have said, what is the probability, let's say, rolling, let's just say even number. So on a fair die, or on a die, even number. So the probability of rolling an even number, well, how many even numbers can I roll? Again, there's 2, 4, and 6. So there's 3 different even numbers I can roll out of a total 6 numbers on the die. So what is the chances of rolling an even number? Half. And that makes sense because half of the numbers on the die are even, half are odd. So you do have 1, 3, and 5 are odd numbers on the die. So anyway, just want to make sure we kind of go over that because that will be a question. Now the next thing is we've done Venn diagrams, but the main thing I want you to understand with these questions is when you see or. So this question says, how many of the students play soccer or basketball? That is the same thing as a union. So you'll see this little U here. That's the same thing as the union we've been talking about. Whereas if you see and, that's kind of the same thing as the intersection symbol that we talked about. So I'm gonna just real quick go through all these 4 questions. How many students play volleyball? Now, the wrong answer a lot of people would put would be 3. But 3 doesn't represent how many people play volleyball. 3 represents how many people only play volleyball. But the number of people that play volleyball, and let me use red here because that'll be a little bit easier to see, would be any amount of people in this circle. So that would be 3, 2, and 2. So 3, 2, and 2 is 7. So I just want to make sure that's clear. A lot of people would put 3 there instead of 7. All right. Now the next one says, how many students only play volleyball? And I already really answered that. So the 3 here represents only volleyball. Whereas if I said how many people only play basketball, it'd be 3. If I said only soccer, it'd be 5. So 3. All right. So the main questions here, the 9 and 10, we're not going to do 11 and 12. I just want to look at 9 and 10. But it says how many students play volleyball and basketball? Now this is the intersection question. And basically what that means is we want to find out where volleyball and basketball intersect. So where volleyball and basketball intersect is this section here. This is where volleyball and basketball intersect. So the question basically is how many numbers are in there? Well, we have 2 and 0, which is just 2. So there are 2 students who play volleyball and basketball. So again, when you see and, that's talking about an intersection or where they overlap in a Venn diagram. Now when it says or, so it says how many of the students play soccer or basketball. So now we're looking at soccer and basketball. That's the same thing as union, which means, if you remember with union, that means you count everything. If it's in either soccer or basketball or both, then it's part of that problem. So what that means is I'm going to count everything that's in basketball, either in soccer or basketball. So we're going to count all of those. So again, union means you count all of them. So I'm putting them all together. So that would be 5 plus 2 is 7, plus 2 is 9, plus 1 is 10, plus 3 is 13, and plus 0 is still 13. So just wanted to make sure I go over the and or thing, because that will confuse people. And then the last question I wanted to go over is another probability. And I know a lot of you may not play with cards. Cards was a big thing when I was growing up, but you know, with y'all having devices and phones or whatever, y'all don't really, not many kids play cards anymore. So, you know, we'll give you this little drawing here because that's going to be important with this question. But what you'll notice is there's 4 different shapes, and it goes ace through king. Okay, so I'm just going to do these 4 questions. It says a card is drawn from a well-shuffled pack of 52 cards. Find the probability of a 2 of spades. And so again, we're still using this equation here. Well, how many 2 of spades are in the deck? Well, there's only one. This is a 2 of spades, by the way. These are called spades. These are called clubs. These are called hearts. These are called diamonds. Okay, so there's only one 2 of spade. And then it says, so that's the event. How many different ways can that event happen? And then the total outcomes, meaning how many cards are in the deck. Well, there's 52 cards. By the way, each shape has 13 cards. So the probability of getting a 2 of spades would just be 1 out of 52. Now here it says a black face card. So the question is how many black face cards are there? And when we say face card, we're talking about Jack, Queen, and King. So these 3 here are black face cards, and these 3 here are black face cards. So how many black face cards do we have? Well, 6. So again, that's the event. So when we talk about the event, which goes on top, that's how many ways that event can happen, and then, of course, the total outcomes. So there's 6 different ways we can get a black face card out of a total 52 cards. And that reduces to, let's see, I think 3 goes in that twice. Oh no, not 3. Does 3 go into 52? No. I'm not doing my math right. Well, we know 2 goes in there. So 2 goes in that 3 times. 2 goes in that 26 times. So it reduces to 326. Now here it's asking what's the probability of getting a jack. So again, how many jacks are in the deck? So let me erase this here. Alright, so how many jacks are in the deck? Well, there's 4. There's 1, 2, 3, 4. So then that would be 4 out of 52, which reduces to 1 out of 13. Okay, and then a black card. Well, how many black cards are there? Well, there are this many. Now you could kind of save some time. You know that half of the cards are black, so then the probability would be half. But you could count all these black cards, which is 26. So there's 26 black cards out of a total of 52, which does reduce to 1/2. So half of the cards are black cards, so there's a 50% chance of getting black cards. So hopefully this helps. I know this is a somewhat long video, but it's meant to help you with these questions, which shouldn't take too long. Please email me if you have any questions.